Welcome to our first module, derivatives. Now, before we start reviewing our calculus, let's first talk about some of the terminology and notation we will be using in this course. Whenever we talk about derivatives, we will refer to dependent variables as functions, which depend on variables. Most of the time, the function will be written as the dependent variable, and the independent variables will be placed in parentheses. Some functions can depend on more than one variable. The reason it's important to note this is because by expressing physical phenomena as functions, we can apply all sorts of mathematical operations to it. One of the most basic applications we can do is to graph a function, which allows us to visualize it. Next, we'll talk about differentials. This is the D operator you use when you take a derivative. Simply put, this differential represents a change in a property, but not just any change. A very, very small change. Suppose you're mapping the position of a moving body. Perhaps your first position is at x, and after moving a distance delta x, your second position will be x plus delta x. Now the change in position delta x will determine your second location. Perhaps we want to make delta x smaller, so that we can really examine that change. Maybe smaller than that. In fact, let's make delta x so small, so infinitesimally small, that we can't really quantify that change numerically. When we get to a change that's infinitesimally small, we call it a differential. In this case, that change will be expressed as dx. So then, what is a derivative? The derivative, simply put, is a very, very small change in a function with respect to a very, very small change in a variable. In other words, if a function y depends on x, and x undergoes an infinitesimally small change, it follows that y may also undergo an infinitesimally small change. We can quantify this change with a derivative. Most of you taking this course have already taken a calculus class, in high school or in college. In that class, you probably learned about derivatives in terms of limits. So let's give that definition as well. Suppose you have a function y, and you would like to know the slope of that function. One thing we can do is to select 2 points along the curve at locations x and x plus delta x, and divide the rise over the run to determine the slope. However, your slope will vary depending on which points you select. Now, if we just want to find the slope at an instantaneous location, then we can just select 2 points that are very, very close to each other. In fact, so close that the distance between them, delta x, is almost 0. We say that it tends towards 0. At this short distance, the rise is a differential change in y, and the run is a differential change in x. That's our derivative. For example, let's find the derivative of a function x squared. Taking our definition of limits, we see that the derivative of x squared with respect to x will be the limit of x plus delta x squared minus x squared divided over delta x as delta x approaches 0. We can do a little bit of math here to end up with the limit of 2x plus delta x as delta x approaches 0. Now, of course, as delta x approaches 0, then we are left only with 2x. And that's it. That's our derivative. The derivative of x squared with respect to x is just 2x.